Hi, I'm going to solve quiz 3 for week 7 that says like this. The wave function for a wave on a touch string is y equals to 0.35 meters sine of 10 pt, that is the time, minus 3px, that is the distance, plus p quarters. Okay, I'm gonna write it here. It's like this in terms of x and in terms of t, and this it's equal to 0.35 meters, and this times the sine of 10 pi times minus 3 pi x, that is distance, plus p quarters, and this is our function. So we know that t is in seconds and x is in meters, and first of all we have to calculate what is the average rate at which energy is transmitted along the string in the liter mass with a mass density with a linear mass density of, I'm gonna write it here, the linear mass density, it's equal to 75 grams over meter. So we're asked the average rate, and we know that the average rate is equivalent to the power. So we know here that for the power we will have two different equations. The first equation says that power is equal to the energy over the time, but this one we are not going to use it right now. And the other equation of power says that the power is half of the linear density times the angular frequency square times the amplitude square times the velocity, okay? And by watching here the equation, we can see that we have the amplitude, we have the linear, the angular frequency, and we have also here the constant kappa here. So once we know this, I'm gonna write this data over here. We have the angular frequency, it's equal to 10 pi radians over second, that is this one, and we also have this one, that is our kappa, that is 3 pi radians over meter, okay? And well, we also know our amplitude, that is this one, our amplitude, it's equal to 0.35 meters. Okay. Now we know these values, we can assume for calculating the velocity, that the velocity we know that it's lambda, that it's the length of the wave, lambda times the frequency, it's equal to lambda times the frequency, it's equal to the velocity. So this is equal to the angular frequency times our kappa. Okay, and once we have this one, we can see that this one is 10 pi, and our kappa is 3 pi. So this will be equal to 10 thirds, that it's equal to 3.33 watts. Well, not watts. This is the velocity. The velocity is in meters over second. And once we know our velocity, we have to use this value to obtain our power. Okay? Then we know we have here our equation, and the only thing we have to do is we substitute these values inside this equation. So here we will have half of the linear density that is given here, 75 times our angular frequency, that is this one, 10 pi squared, times our amplitude, 0.35, also squared, and times our velocity, that was 3.33 meters over second. And once we calculate this equation, we will obtain that the power, the average power, is equal to 15.1 watts. And this is the result for the first part. The second part says that we have to calculate the energy contained in each cycle of the wave, in one cycle. Okay, for calculating that, we will use now our equation of power that contains energy and time. But the time in one cycle is equal to a period. So for obtaining the period, we will use this equation, that is the angular frequency. It's equal to 2 pi over the period. So if we get out the period of the equation, we will obtain that the period is equal to 2 pi over our angular frequency, that is equal to 10 pi. So here we will have 10 pi, and the pi goes away, and we obtain 1/5 second. So we know that one period is equal to 1/5 of the second. Okay, once we have this value for the period, then we can use our equation for the power, that is equal to the energy times the time. But we are asked to obtain the energy, not the power. So once we have our power, that it's given over here, we only have to substitute. We have to switch these two constant, well, these two variables, and we will have that the E energy, it's equal to the power times the time. But at the same time, the power is 15.1 times the time. We said that was 1/5 of the second, and this is equal to 3.02 joules. And this is the result of this quiz.